Chapter number 2, Function and Graphs. 2.1, the modulus function or absolute value function. So we are going to discuss the modulus or absolute value function. The modulus sign is this one. For example, modulus 2 is 2. Modulus of minus 2 is also 2. Modulus of 3 is 3. Modulus of minus 3 also 3. So the task of this function is turn all negative value to positive value, the magnitude. So if it is 2, just 2. If it is negative, then turn into a positive. So this is the task of the modulus function. We turn into a value to a magnitude. We filter the magnitude. So what is really happening in this modulus function? For example, if this is the function, so we will put a number. If it is positive, then print. If it is negative, multiply by minus. Multiply by negative and print. So when you put 2, so then recognize it is positive. So just print 2. If you put negative 2, so recognize it is negative, then multiply by minus. So negative 2 multiply by negative. I can write like this. It's become positive. So then it's become 2. If it is positive, just print it or just write it. If it is negative, multiply by negative and print it or write it. So that's how the modulus function work. Basically, we turn positive, the turn value into a positive numbers, which is magnitude in other way. So recognize if it is positive, print that one. If it is negative, multiply by negative and print it. So that's the task of the modulus. Or as mentioned in the book, the modulus of number A. So we write in this one written as, so this one we write as mod A. So it is the non-negative numeric value. So modulus of minus 2 is what? Non-negative is 2. So this is non-negative of numeric value. We write this one y equal fx, assume fx function. So this is the modulus function. If fx greater than or equal to 0, then modular fx is fx. When you take a fx equal to, so it is greater than 0, then modular fx is 2. If fx is less than 0, then modular fx is negative fx. It means if it is less than 0, assume fx equal minus 2, then it's going to be minus, and what is the fx now? Negative 2. So negative times negative, positive, it becomes positive. Also we can write modular x as a function. This is x if x less than, greater than or equal to 0. This is minus x if x less than 0. As you, when you take 2, when you look at 2, so 2 is greater than or equal to 0. Then the answer is 2. If we put negative 2, then you recognize 2, negative 2 is less than 0. Then the answer is negative negative 2. Negative negative means positive. This is positive 2. So this is the modulus x. If we want, we can write y equal modulus x. Example 1. We want to find the modulus of these three numbers. If it is negative, we have to multiply by negative and write, which is 2. If it is positive, print as it is. Now in this one, we have to simplify. So this is going to be 15, and this is 5 minus 12. So this is going to be minus 7 over 15. So modulus minus 7 over 15 equal 7 over 15. Example 2, it's given 2x minus 3. So this is the modulus, and plus 1. Then we want to find f5. This is the first one, the second one, and the third one, f minus 2. So we'll work out now. F5 e. Instead of x, I'll substitute 5. So this is going to be 2 times 5 minus 3 plus 1. So this is going to be 10 minus 3, 7 plus 1. Modulus of 7 is what? 7. So our answer is 8. Part B, minus 2. F minus 2. So this is going to be 2 times minus 2. 2 times minus 2 minus 3. I just substitute plus 1. So this is minus 4 minus 3 plus 1. So this is minus 7 plus 1. So what is the modulus of minus 7? So modulus of minus 7 is 7 plus 1, 8. And C, F1 equal modulus of, this is 2 times 1 minus 3 plus 1. So this is going to be 2 minus 3 plus 1. This is minus 1 plus 1. So what is the module of minus 1 is 1. So 1 plus 1 is 2. Now we will draw y equal x graph and y equal modulus x graph to understand how the modulus work in or behave in a graph. For this I will pick up a few values, -3, -2, -1, 0, 1, 2, 3, and this is x values, and this is y values. So when we substitute here for y equal x graph, yn equal y equal x. So x equal -2, y also -2, -1, 0, 1, 2, 3. So then we can draw the graph. This is x and y axis. So this is -3, 3. So -3, 3 is going to be here. So this is 1 point. Other one is -2, 2. Then -1, 1, 0, 0. Then 1, 1. And then 2, 2. And then 3, 3. So the graph is going to be like this. You know, this is y equal x graph, very simple graph we do in GCSE, y equal x graph. Now we'll draw this table to y equal modulus x. So x, and this is y value, so y equal modulus x. So -3, -2, -1, 0, 1, 2, 3. Then this is going to be -3 modulus -3 is 3, -2 modulus is 2, -1. So when you substitute modulus -1 is 1, and 0, and 1 modulus 1, 2 modulus 2, 3. So basically for modulus, this whole value become positive. You can rewrite if you want. This is x and x. This is x and modulus x. When you substitute, they all become positive. Now we'll mark this in. So 3, 3. So that point is going to be the same. Then 2, 2. So it is still the same point. And 1, 1. And it's still the same point. And 0, 0. And then x equal -1. Then what is the y value? Y value is going to be positive 1 now. So it is here. So instead of this distance, now it is here. So this is the, and when x equal -2, in this graph it is -2, but according to this one mod value, it is going to be 2, 2. And when x equal -3, what will happen? This is, now the mod graph is this. Same it will come, but so this is going to be y equal mod x. Now what is your observation? What is the difference between x and modulus x? X graph, you can find negative y values. So those are y values. But for modulus graph, you can't find any negative y values. They all are positive. So in modulus graph, all y values are negative. For any x, for any x number, negative or positive, all y values are positive. So basically, if you bring a mirror and keep in this line x-axis, if the ray comes like this and it is reflect like this, so it is basically a mirror reflection. Assume you have a graph like this. Now this is y equal fx. What is the y equal modulo fx? Then you want to bring a mirror and you want to keep like this, then this will come, this curve come like this, the line come like this, and then this is 90 degrees perpendicular, and this is the mirror reflection of this line. So this is y equal modulus fx. That's how you make this negative distance to positive. You take this negative things and put into positive. Negative to positive. So all these negative distances you are turning into a positive by multiplying minus. Let's discuss example number 3. In example 3, we want to draw y equal 3x minus 2 modulus graph. So to do this one, first of all, we will consider y equal 3x minus 2. And we can draw this one as usual. So we know that first of all roots. When y equals 0, 0 equal 3x minus 2. So x equal 3 over 2. And we know y-intercept is minus 2. That is 0 minus 2. We'll draw that graph now. So this is going to be, root is at 1.5. This is the line. So this point is 0, 3 over 2. And this is 0 minus 2. Now what will happen when we draw modules? It means we want to bring a mirror and keep in this way. Then when a ray comes like this, and it will reflect with the same angle. If come with 30, so it will go with 30 with the same angle. If this is alpha, this is also alpha, and it go like this. Now what is this value? This value is, we know if this is 0 minus 2, this is going to be 0, 2 by the symmetricity. This is x and this is y. Now how do you draw without drawing this line? Y equal 3x minus 2. What you could do, still you want to follow this step, y equal 3x minus 2, then you need to follow the roots, identify the roots. Then you don't have a graph now. You are going to draw this one now without mirror reflection concept. So you found out root. Now root is 0, 3 over 2. So 0, 3 over 2. So this is the point you know that it is going to turn. So take any other point beyond that x value. So x equal let's say 3, then y equal 3 times 3 minus 2, that is 9 minus 2. I will put x equal to reasonable value. Okay, I'll stay with 3. 9 minus 2, 7. So one coordinate is 3, 7. So I know that this is 1.5, then another 1.5, 3, this is 7. So this is the 3, 7 point. Then you can merge this one. Then you know that when x equals 0, yeah, you find y-intercept. Y equal 3 times 0 minus 2, that is 2. So this is going to be 0, 2. Then this is 7, this is 3.5, somewhere here. So this is 0, 2, another point. So then you can draw like this, finding 3 points, because 2 lines, one is common, the root is common, and then you need to find other 2 points, then you can do. Example 4. This is an equation we have to solve. There are 2 equations. One is y equal to 2x minus modulus 2x minus 1, and the other one is y equal 5. When we try to solve, what do we do? So we make equal 1 equal 2, then modulus 2x minus 1 equal 5. Now this sum is in this step. So basically this is a which point? Intersection point of those two graphs. Then we want to draw graphically. If we need to find, we want to draw this one first. So y equal 2x minus 1. Then how do we draw this one? First of all, we want, okay, we'll draw properly. Y equal modulus 2x minus 1 roots. So y equal 2x minus 1 we consider. Then let y equal 0, then x equal half. So half a 0 is the root. So this is half a 0. And then we'll take one more point when x equal, okay, we'll consider now the y-intercept. So y equal to x minus 1 modulus. When x equals 0, y equal negative 1 is 1. So that is going to be 0, 1. So I'll draw something like this. So this is the graph. So this is y equal modulus 2x minus 1. And this one is y equal 5. So we can draw y equal 5. Then we know these 2 points when we draw with the scales, and we can read what are the x values and we know already y value is 5 actually. So from here we can read x values and we can substitute. So this is the graphical method. So if you draw properly, you will get this value is minus 2, and this is minus 2, 5, this is 3, 5. So we graphically solve this one. So we draw this one and we found the intersection point. Now we are going to solve and we are going to find those 2 points. Now we want to solve y equal modulus 2x minus 1 and y equal 5. So how do you find the intersection point? So we have to solve simultaneously. The first step is the substitution method, the easy method. This is 1 and this is 2. Then we are writing 1 equal to add both twice, or 1 substitute to 2. You can do express the way you want. So finally you will get 2x minus 5. You can see in page 24 that they introduced this one. The argument, the function inside the modules is called the argument. So this is a new word you can use when you see a function inside the modules. Now assume there is a value here. This is 2. But this value after taking modulus. Right? So then what you can tell about the values? So those values either it can be positive or negative. When you put positive, still the modulus of this one positive. If you put negative, then it will turn into a positive. Hence, if you want to get rid of modulus, then you have to introduce two values. One is plus 2 and other one is minus 2. If you want to get rid of 2x minus 1 modulus, then you have to introduce two cases. One is positive 2x minus 1, other one is negative 2x minus 1. By keeping modules, we can't solve this equation. So we have to take the modules out. So when you take the modules out, it's going to be two cases. One is positive case, another one is negative case. So we'll discuss case 1. Positive 2x minus 1 equal 5. So that is 2x minus 1 equal 2x equals 6. X equals 6 divided by 3. So x equals 3. We found out x value. Then we know that is the value. The case 2. Negative 2x minus 1 equal 5. Then minus negative plus 1 equal 5. So this is going to be 2x equal 1 minus 5, which is minus 4. So x equal minus 2. You can do this one as well. This is not wrong. 2x minus 1 equal plus or minus 5. So instead of introducing this scenario, we introduce the right, not the, it's not the right theory, but it works. So 2x minus 1 is 5 one case, 2x minus 1 is minus 5 another case. So this will give 2x equals 6, x equal 3. This is 2x equal minus 4 and x equal minus 2. You will get the same answer. You can see that from here. So for positive, it is going to be the same. For negative, so negative in this case, negative in left side. Here negative is right side. So we know that if we have this step, what will happen if you multiply by negative both sides? Then this becomes negative equal minus 5. So that is there now. And you can write like this. So this is not going to be changed. 2x minus 1 equal 5. So you write the second case like this and multiply by minus and take to the other side. Now for this sum it is good, but if I write another example, if we have sum to solve like this, yeah, it is crystal clear. Writing this one is, so you can do x4 minus 3x square plus 8x plus 9 equal 5. Then other one is you can write x4 minus 3x square plus 8x plus 9 equal 5. Then by 3x square plus 8x plus 9 equal minus, bring to other side, it's minus 5 by multiplying by minus. Instead of doing this, so you can straight put plus or minus 5 here. It's depend on the marking scheme. So stay with the previous method, write proper way and bring the negative to other side. Example 5, we can see now there are two equations we need to solve. The first step is substituting or equating, then we will get 3x minus 5. So we are going to find the intersection point. So 2 minus half x. Then we have case 1. So 3x minus 5 equal 2 minus half x. So this is positive case. So then 3x plus half x equal 5 plus 2. So this is 7 over 2x equal 7. So x equal, this is going to be 2. Now case 2, minus 3x minus 5 equal half minus 2 minus half x. I'll bring minus to other side. So this is going to be minus half x. Minus 1 plus half x. So 3x minus 5. Then this is going to be 3x minus half x equal 5 minus 1, 4. This is going to be 3 minus half, 2 and half, which is 5 divided by 2, x. So x equal, this is going to be, sorry, this is not 1, this is 2. So minus 2. So this is 3. So x is going to be 6 over 5. You can work like this as well. So instead of taking minus to other side, we can work like this, minus 3x plus 5 equal 2 minus half x. So we'll take 3x to make into negative. So this is plus 5 minus 2 equal 3x minus half x. So this is going to be 5 over 2x equal 3. So this is going to be x equal 6 over 5.